Do material particles behave like waves? This led to one of the revolutionary ideas in modern physics.
So, development of quantum mechanical model of atom. The quantum mechanical model of atom जो है इसके दो fundamental principles हैं. It is based on two fundamental principles. One is de Broglie hypothesis and another is Heisenberg's sensitivity principle. And let us go for the de Broglie hypothesis. De Broglie hypothesis हमें क्या कहता है? De Broglie हमें पता है कि already de Broglie ने क्या कहा? De Broglie ने कहा कि अगर यूनिवर्स की बात करेंगे, यूनिवर्स जो है दो चीजों का बना हुआ है, होता है एक मैटर का और एक एनर्जी का. एनर्जी मीन्स लाइट. If energy, light is having a dual character, that means this universe is symmetrical. Matter should be also having a dual character. So he advanced in 1924. He's a French physicist. He advanced the idea of dual nature of radiations and said that like light is having a dual character. Likewise, a moving material particle like an electron, proton, neutron, or a moving bus, or a car, or a tennis ball is also having a dual character. Means that moving material particle sometimes behaves as a wave and sometimes as a particle. Or we can say a wave is associated with a moving material particle which controls it in every respect. That material wave is called as, yes, उस material wave को हम क्या नाम लेते हैं? We call that matter wave, and that is or a de Broglie wave. और उसकी एक wavelength होती है, उसको हम क्या कहते हैं? De Broglie wavelength. And he gave a relationship where he connects the particle character of momentum with the wave character of wavelength of the matter wave and give a relationship, and that relationship is equal to that relationship क्या है? Lambda is equal to h by mv. So अगर हम इस equation को derive करेंगे, how we are deriving this equation, we are taking an analogy of a photon. हमें पता है कि photon जो होते हैं उसकी जो energy होती है वो as per the Max Planck's quantum theory वो होती है equivalent to h nu, where mu is the frequency of that discrete photon. So as we know that in case of an electromagnetic radiation which is traveling with the speed of the light, that mu is equal to c over lambda. So substitute the value of mu, we will get E equal to hc by lambda. But this is the one equation. And another equation हमारी जो है as per the Einstein's mass energy equivalence, जहाँ पे हमें क्या होता है, mass जो है can be converted into energy and energy can be converted into mass, and according to that the energy of the photon will be equal to mc square. So since this is energy, this is the energy, if we are comparing these equations, left hand sides are equal, so their right hand sides will be also equal. तो इसका मतलब है hc by lambda will be equivalent to mc square. तो यहाँ पे c cancel हुआ तो h by lambda will be mc और lambda is equal to h by mc. So this is the wavelength of the photon. This is the wavelength of the photon. So I am taking any moving material particle where this velocity of the light will be replaced by the velocity of the particle v, and then lambda will be equal to h by mv. So this is the relationship derived here. Clear? अब इसकी significance क्या है इस relationship की, de Broglie's relation की? इसकी significance ये है कि it is having an utmost significance in case of moving microscopic material particles which is having a negligible mass, because there they will be having a dominant wave character, and in case of bodies which are having a huge mass, there it is insignificant. This relationship is insignificant. वो हम understand करते हैं by taking a simple example. अगर हमने एक बाल ली जिसका वजन हमने लिया 200 grams and when it is moving with a velocity of 200 meters per second, and we are solving this, we will get a wavelength of 10 to the power minus 35 meters. Means that ball which is having a mass of 0.2 kilograms and moving with a velocity of 200 meters per second, it is having a negligible wavelength of 10 to the power minus 35 meters, and which indicates that a material object, that which is a ball moving with a velocity of 200 meters per second, it is having a dominant particle character and the insignificant wave character. Likewise, if I take an electron revolving around the nucleus, we know that mass of an electron is 9 into 10 to the power minus 31 kilograms. And if let us suppose its velocity, the first Bohr's orbit, it as calculated by Bohr, it is around 2 into 10 to the power 6 meters per second. Substitute the values. When we are substituting the value, we are getting the wavelength of 331 picometers. So that is having a significant wavelength. An electron is having a significant wavelength. We got a significant wavelength. It means that the electron in an atom is not behaving only as a particle, but it is also having a significant wave character. That means it is having a dual character in it. This is how it performs.
Do follow and subscribe for more interesting videos.